Hello, class. I'm here with another example for you of finding area by relating it to definite integrals. Okay. So here we're looking at the graph of the function y equals 1 plus x squared, and then I've taken sort of a horizontal slice out of the middle of this graph. So as before, I think it's important to find the intersections, because these are certainly going to dictate what's happening. Okay. So you can find the intersections by setting the equations equal. So this is the intersection of 1/2 and 1 plus 1 over x squared. So I'll do that. Okay, so cross multiplying, that says that x squared plus 1 is 2, so x squared is 1. So x is plus or minus 1. This is certainly the x that's at plus 1. So this is 1/1/2. Okay. This intersection, this is where 1 over 1 plus x squared equals 1/4. So that is 1 plus x squared equals 4. So x squared is 3. So x is plus or minus the square root of 3. Certainly this is the plus square root of 3 one. And so this is positive square root of 3, comma 1/4. Okay. So I want to go ahead and drop verticals down to the axis, because the definite integral tends to involve these verticals down to the axis. And I want to try and figure out how we're going to put this area together. Okay. Notice this is just the y-axis, so this is x equals 0 is where this is starting. So that this is 0, this is 1, and this is the square root of 3 going along there. Okay. Now I want to figure out the black area. Now, how am I going to do that? Well, I'm going to try and break it up across this piece. And if I squint, it's not so hard to convince myself that if I look at this thing, which I'm going to label A, that's a rectangle. In fact, it's a rectangle that is 1 wide and 1/2 minus 1/4 tall. So 1/2 minus 1/4 is 1/4. Okay. So the area of A is just 1 times 1/4, which is 1/4. So what's left is to find this region, the orange region. And that's not immediately something that leaps out at me as to how I'm supposed to do. But if I combine the orange region with this green region, which notice is not part of the black region, but if I put these two things together, then what I get is that this actually, the orange and the green together, they give me an area that I could calculate with a definite integral, because the orange and green regions together are a region that is between the graph of 1 over 1 plus x squared and the x-axis. So writing that down, orange plus green equals the integral from 1 to the square root of 3 of 1 over 1 plus x squared, and I'll go ahead and put the dx there in the numerator. Okay, so let's continue. What is that? Okay. Well, I need to find the antiderivative. So this is still orange plus green. I need to find the antiderivative of 1 over 1 plus x squared, which I will recall is actually one of our inverse trig functions. That's inverse tangent. So this is inverse tangent of x, evaluated as x goes from 1 to the square root of 3. And so this is inverse tangent of square root of 3 minus inverse tangent of 1. And these are both things that I have to look up from my unit circle, but this one works out to be pi over 3 minus, and this one's pi over 4. Okay, so if I put these both over 12, that's 4 pi over 12 minus 3 pi over 12. It's just pi over 12. Okay, so that is, I'll remind you, the orange plus the green area is pi over 12. Okay, now I have to figure out how I'm going to put all of this together, because I really just want the orange area. Okay, that's what I want. I don't care about the green area. The only reason I care about the green area is that I could calculate the orange and green area together. But here is where I'm lucky again. The green area is a rectangle. So the green area since it's a rectangle, it is just, well, this rectangle is 1/4 high, and it is root 3 minus 1 wide. Okay, so this rectangle has area 1/4 times the square root of 3 minus 1. Okay, well, I know the area of the orange and green region together, and I know the area of the green region, so that lets me figure out the area of the orange region. Namely, the orange area is pi over 12 minus 1/4 times the square root of 3 minus 1. Okay. And now, if we pay close attention, we're actually done, because the thing I wanted is the black area, and the black area is the blue area plus the orange area, and I know the blue area, and I know the orange area. So the black area, the area that we're looking for, it happens to be 1/4 for the blue area plus pi over 12 minus 1/4 times the square root of 3 plus 1/4. That all is the orange area. Okay, and the only thing you can really simplify here is that that plus a fourth and that plus a fourth actually add together. So this ends up being 1/2 plus pi over 12 minus root 3 over 4. That is our final answer for what the area is of this wedge. Okay. I will do one more example of this in the next video, but until next time, be well.